So this is an application problem, something that happens in the real world. And they give us some information on the risk of accidents based on the blood alcohol level. So it says medical research indicates that the risk of having a car accident increases exponentially as the concentration of alcohol in the blood increases. So more alcohol in the blood, the greater chance that you're going to have a car accident. And that is an exponential model. Okay. So the risk is modeled by, and there's our exponential model. And it says X is the blood alcohol concentration. So the input is your blood alcohol or someone's blood alcohol concentration, and R, given as a percent, is the risk of having a car accident. What blood alcohol concentration corresponds to a 17% risk of a car accident? How is this shown on the graph? Okay, so here's the model. And we know the risk, right? We know the R. So the R is 17. Okay, so I got to keep that in mind. So there's my model, and I'm going to put 17 equals 6 e to the 12.77x. And I want to solve for x. Now, if you don't like writing it that way, you could put it the other way. So you could put 6 e to the 12.77x equals 17. That would be okay. You don't have to do that, but I'm going to. All right. We want to solve for x. So we have to isolate, remember, we have to isolate the exponential part. So I need to divide both sides by 6. So that can be a fooler. Sometimes our eye doesn't say, hey, let's divide by 6. But we need to look for that. We only get to have a base to an exponent. Okay, it is not base 10, so we're going to take the natural log of both sides. So we just insert natural log e to the 12.77x equals natural log. And then we're going to have to use parentheses here, 17 divided by 6. Now you might be saying sometimes people are tempted to just get a decimal approximation for 17.6. You don't want to do that. You don't really want to round stuff off early on in the calculation. It can make your answer off by quite a bit. So we'll save that till we put it in our calculator. Okay, now this is property 3 because the base here is the same as the base in the argument, so it just is that exponent. 12.77x equals the natural log of 17 over 6. Okay, so we're almost done. We just have to divide both sides by 12.77. Now, we don't know where the 12.77 comes from. That's some constant they figured out. So x equals the natural log of, oops, that's supposed to be a parenthesis, 17 over 6, parenthesis, divided by 12.77. So we are going to put that in our calculator, and we're going to go 2 decimal places. Let me grab my calculator. And I'm going natural log, opens the parenthesis. I put 17 divided by 6, close that parenthesis. Don't forget you got to close that off. Divided by 12.77. And I get 0.08. Okay, so that means that if there's a 17% chance of having an accident, the blood alcohol is approximately 0.08. I guess you should say if someone had a blood alcohol level of 0.08, then they have a 17% chance of being in a car accident. Now they ask about the graph. So here's my answer. This is the exact answer. They probably want the decimal approximation though. On the graph, what does that look like? Well, it's the x that we found, and that was 0.08, which is about there. So you go up, and then you read across, and I don't know, does it look like 17? It's fairly close. Mine looks more like, yeah, maybe it looks like 17. So it's 16. I don't know. Okay, so that's how it shows on the graph right there. Okay, the input was X, the blood alcohol level. The output was the risk of the car accident, which was a percentage, and it was 17%. Okay.